Assalamualaikum warahmatullahi wabarakatuh. I am Anis Maisara binti Azmi. I am from Fakulty Mechanical Engineering from University Malaysia Pahang. Today, my group will present about the energy efficient vehicle, which is we call it as EEV. Okay, now I will explain the introduction of EEV. So, energy efficient vehicles, or we know as EEVs, are type of green transportation that reduce CO2 carbon dioxide emission and eliminates the use of fossil fuels. Malaysia, as an oil producing country, must conserve resources and diversify its reliance on fuel combustion engines and their hazardous emission. Malaysia has established EEV production objectives and implemented many measures in recent years to minimize greenhouse gas emission while satisfying the expanding energy demands of the transportation sector. And this research assessed the efficacy and execution of current EEV policies and initiatives. It is worthwhile to determine the important aspects that must be in place for the government to push for EEV adoption. Passenger vehicles that use alternative fuels, as defined by the Energy Policy Act of 1992, hybrid electrical vehicle, which we call it HEV, conventional gasoline vehicles achieving an average fuel economy at least 25 ml per gallon, or vehicles powered by ultra low sulfur diesel achieving an average fuel economy of at least 30 ml per gallon, are classified as energy efficient vehicles. State agencies should also employ ethanol and biodiesel in suitable state-owned vehicles wherever possible and encourage the development of biofuels fueling infrastructure. Now I will explain why we need to choose electric car, or why electric car is better. There are three reasons why electric car is better. The first one is electric vehicles save our climate and lives. Humans need to make our roadways as clean as possible in order to tackle the climate catastrophe. To avoid the worst impacts of climate change, we barely have another decade to modify the way we use energy. Car and truck emissions are not only harmful for the environment, but they are also hazardous for human health. Asthma, bronchitis, cancer, and early mortality are all caused by contaminants in the air from gasoline and diesel automobiles. Local air pollution has long-term health consequences manifesting as asthma attacks, lung damage, and heart issues. Okay, the next one is electric vehicles have a smaller carbon footprint than gasoline power cars. The power grid, which use a range of sources ranging from fossil fuels to clean renewable energy, provides the electricity that charge and fills electric batteries and plug-in hybrid automobiles. Since the electricity system varies from state to state, the carbon footprint of an electric vehicle varies depending on its power source. Although renewable energy already outnumbers coal, a portion of the country's power will continue to be generated by burning fossil fuels. Electric vehicles are more efficient at converting energy to drive cars and trucks, and electricity is cleaner and less expensive as a vehicle fuel, even when it comes from the dirtiest grid. According to research by specialists at the Union of Concerned Scientists, driving electric hybrid automobiles on the grid in any state emits less greenhouse gas than driving gasoline power cars. The advantage of electric cars gets stronger as states clean up their electricity system. Okay, the third one, which is electric vehicles can be charged at many places. Electric cars have the benefit of being able to be recharged almost anywhere, whether it's your home or a bus terminal. This makes electric vehicles an attractive option for truck and bus fleets that visit a central depot on a regular basis. New recharging options, such as providing additional public charging spots in shopping malls, parking garage, and workplace, will be necessary as more electric vehicles hit the market and are utilized more widely for people and companies that do not have the same access at home. Next, I will explain about the electric vehicle technologies. So, for the electric vehicle technologies, I will focus on the electric vehicle regenerative braking modes. Regenerative braking is the most visible difference between driving an electric car and a standard ICE vehicle. Regenerative braking refers to the operation of an electric motor in reverse, which applies a braking force via electromagnetism. By charging the battery, some of the vehicle's kinetic energy is recaptured. Specific driving modes with a variable amount of regenerative braking are available on several electric car types. When a driver takes their foot from the accelerator pedal in a typical driving situation, an electric vehicle like the Tesla Model S employs regenerative braking to decelerate the car. The standard option delivers the higher regenerative braking power, capturing the most energy while reducing brake wear and tear. The low setting, on the other hand, features a lower regenerative braking force, which absorbs less energy but allows the car to coast further than in standard mode. When vehicles is stopped or traveling at very slow speeds, an electric vehicle like the Tesla Model S has unique setting for how the braking system functions. The creep setting is supposed to mimic an ICE vehicle's idle pace. While stopped or at low speeds, when the driver's foot is off the accelerator, it is disengaged regenerative braking and applies a tiny amount of motor thrust. When looking for a parking spot in a parking lot, this function is most usually used. The roll mode, on the other hand, disables regenerative braking at low speeds but does not apply motor thrust. This lets the car to roll about freely, just like it would in neutral. Finally, the hold setting keeps regenerative braking engaged until the car comes to a complete stop, which reduces brake wear and provides the most energy retrieve. When the car comes to a complete stop, this function automatically activates the friction brakes, which hold the vehicles in place until the driver's foot is placed on the brake or accelerator. Okay, next I will explain the electric vehicle mechanical composition. All electric cars, often known as battery electric vehicles, or we call it BEVs, store the electrical energies that drives a motor in battery pack. Plugging the car into an electrical power source charge the battery. Electric vehicles, both heavy and light duty, are commercially accessible. BEVs are normally more expensive than conventional and hybrid cars, while some of the expenses might be mitigated by fuel savings, federal tax credits, or state incentives. So this is the component of General Electric car, and I will explain the function of each component of General Electric car. So the first one is the battery. The battery in an electric car provides electricity to power vehicle accessories. Next is charge port. The charging port allows the vehicle to charge the traction battery pack by the connecting to an external power source. Next is DC converter. This device converts high voltage DC power from the traction battery pack to the lower voltage DC electricity required to operate vehicle accessories and charge the auxiliary battery. Electric traction motor. This motor powers the vehicles with the help of the traction battery pack. Motor generators are used in certain vehicles to provide both propulsion and regeneration. Net is onboard charger. Converts incoming AC currents supply through the charge connected to DC power for charging the traction battery. While charging the pack, it also connects with the charging equipment and analyzes battery properties including voltage, current, temperature, and state of charge. Next is power electronics controller. This unit controls the speed of the electric traction motor and the torque it produces by managing the flow of electric energy given by the traction battery. The next is thermal system in cooling. This system keeps the engine, electric motor, power electronics, and other components within a safe operating temperature range. The next one is traction battery pack. Electricity is stored here for use by the electric traction motor. And the last one is transmission. The transmission is responsible for transferring mechanical power from the traction motor to the wheels.
Hi, my name is Muhammad Amiruddin bin Ghazi, and today I will present about the vehicle modeling and simulation tools. So before we start do the analysis, we gather the information from the websites about the dimension of car that we use, which is the Nissan Almera 2020. And as you can see here, the wheelbase is the 2535, and this is the design that we choose for our project before we do the analysis using the CFD. And after we get the simulation, now we model it through the SolidWorks to get the 3D model, which is after we do the 3D model, this is the result. So after we success to do the 3D model, and as you can see here, this is the side view of Nissan Almera, and this is the isometric view for Nissan Almera model. And then we do the analysis using the fluid flow simulation at SolidWorks. And as you can see here, we get the isolines data and surface plot data. Okay. Then from the SolidWorks also we can get the airflow data, which is at the top is about the pressure. As we can see, the pressure is green and the higher is red. So, and at the bottom is the airflow data for the velocity. Okay. Now I will explain about the parallel hybrid vehicle design, which is the hybrid electric car has characteristics of both an electric and internal combustion engine, and it runs like an electric car at low speed, which the battery supply the drive power, and the engine and the battery works together to supply the drive power demand at greater speeds, and the distribution and sharing of power between these two sources are important factor in fuel economy. Then the ICE and electric motor are connected in parallel to supply power to the wheel in a parallel hybrid setup. Then mechanical connection is used to combine the power of electric motor and ICE. So the vehicle can be driven with the internal combustion engine, the electric motor, or both at the same time. So I will explain also about the energy management system, which is the main function of EMS would be first to optimize energy flow for better efficiency, and second is to predict available energy and driving range, and it's proposed a suitable battery changing algorithm, and it uses regenerative braking to charge the batteries, and it suggests more efficient driving behavior, and it also report any malfunction and corrects them. Okay, that's all about me. Thank you.
So now I will explain about the road load characteristic. So the road load characteristic has 4 types to be considered. The first one is force torque, and then rolling resistance, Number 3 is aerodynamic resistance and also force power. So vehicle speed, road slope and acceleration all influence the amount of force necessary to move a vehicle. If we suppose we are driving at a constant speed on a flat road with no substantial head or tail wind, the effort necessary to drive the car is divided into two categories, which is rolling resistance and aerodynamic resistance. Rolling resistance was dominant at low speeds, and aero forces are dominant at greater speeds. The magnitude of forces is determined by several parameters, including the vehicle's weight, size, and drag coefficient. In general, a force proportional to the vehicle speed squared can be used to mimic high-speed operation. So next is for the electric motor design. So the first step is to determining the load characteristic. Torque and speed versus time is the first and most crucial stage in electric motor selection. Electric motors are chosen based on mission objective, available power, and cost. For step 2, starting and running torque. Electric motor starting torque requirements can range from a tiny percentage of full load to several times full load torque. And for the last step is gear reducers in electric motor driven system features sections that revolve at various speeds. Rotating components must be reduced to a common base in order to compute the acceleration torque necessary for these electric motors. So here for the internal combustion engine design, based on the graph given below, it shows about the combustion engine flexibility indicates its ability to adjust to varied loads and engine speeds. This is a very important index in determining the operational potential of traction engines. So the dynamics coefficient is a numerical expression of engine dynamics, which given formula for E equals to M max over M and max subtract to N over N max. So for the battery, there are terminology and the battery. So the first one is the electron flow rate or current via a circuit is measured in ampere. Then electrical potential or voltage is measured in volts. Battery is one or more galvanic electrochemical cells electrically connected into a single unit using external electrical connection connectors. And then an electrical circuit is the path that electrons take when they flow. A complete path is referred to as a closed circuit. An open circuit has a route that is broken or unplugged.
A very good day to Dr. Devarajan. My name is Ravin and my matrix number is MH18052. So my contribution for the electric efficient vehicle project is battery modeling, battery electric vehicle simulation and the electric vehicle simulation. So the figure shows how a battery modeling for electric vehicles are done. So the battery type that electric car uses is lithium ion battery. So the figure shows a simulation model of the battery electric vehicle. So moving on to the hybrid electric vehicles, it is regarded as an alternate mode of transportation because pure electric cars lack a suitable supply of energy for driving over long distances, and their recharging process might take a few hours. Hybrid electric vehicles have increased fuel efficiency, and decrease pollutants when compared to conventional automobiles. The efficiencies of two type of vehicles are shown in table below. So it shows the significance of tank to wheel efficiency with TTWE and well to tank efficiency WTTE. So moving on to the electric vehicle simulation, the slide shows the simulation vehicle operation on highway drive cycle, and on the left and on the right is vehicle operation on city drive cycle. So for the conclusion, the importance of electric vehicle cars and their technologies is well explained in this project. CFD analysis of the Nissan Almera model has been interpreted using the flow simulation in software which is SolidWorks. Hybrid electric vehicles are obviously more ecologically friendly than vehicles based on their ICE internal combustion engine. So that's all for the presentation. Thank you so much, Doctor.